Hi, welcome back to our third video for 3.5 transformations of exponential functions. In this video, we're going to combine all the transformations at once. So this is real easy to do. We get to apply the same point mapping formula that we learned in the last chapter. Okay, just to go over this real quickly, this shows our horizontal stretch or compression. This is our horizontal shift. Note the way how these look. It's always the opposite of how it may look in the equation. And then here's our vertical transformations. So our vertical stretch or compression, and then our shift. So I call this the point mapping formula, and it works every time. We were using this formula in the previous examples, except I didn't write it out like this because we only had like one or two happening, and it's pretty easy to understand. Okay, this question is quite simple. Let's just look at our function. So I'm going to have to say, first I have to identify what the base is. So my base is going to be, it looks like it's going to be 2 to the exponent x. So don't pull this negative in with the base. Our base is actually restricted to only positive values. So real quickly, when we have exponential functions, just a reminder that b has to be greater than 0. Okay, we cannot have any negative values for the base, and there's another restriction: base can't equal 1, because 1 raised to any exponent is just 1. So if you can go on Desmos and you can play around with something like this and put in negative values for the base, see what you get. Put in 0, see what you get. Put in 1, and then you'll know why these conditions exist. So anyway, kind of going to get off topic a bit, but so we're trying to graph this, or this is our base function. So now I can see my base function has been multiplied by -1. So that means a is equal to -1. So that means we have a reflection along the x-axis. I also see my exponent up here. When I compare that to this, I can see k. So we'll write that out too as well. K is equal to 2. That means we're going to have a horizontal. Remember, it's going to be a compression because the factor is 1 over k. It's going to be 1 over 2. So by a factor of 1 over 2. Okay, then looking at comparing this again to this, I can see d is 3. So that means we're going to have a horizontal shift, 3 units right. And then the plus 5. So we're going to have a vertical shift up 5 units. Okay, now we really didn't need to write any of this out, but I just want to make sure we can see the transformations. Really, all we just needed was the parameter. So we never needed any of these statements, but we just really want to pick off A, K, D, and C. Once we do that, we're going to plug them into here, and we're going to map our points over. So let's start with the base function. So y equals 2 to the x. We have some base points for x, y, kind of like what we did before. I'm just going to put it in the table this time. Let's pick a couple negative ones, a couple positive ones. So plug in -1. We're going to get 1 over 2, which is a half. Plug in 0. 2 to the 0 is 1. 1 is 2. 2 is 4. All right, so these get mapped over to my new formula. We're going to follow this here. So my x values are going to become x over k. K is 2. And then I got to add d. D is 3, so plus 3. So already I can see a horizontal compression by a half and 3 units to the right for a shift. All right, now for the ay plus c, I want to fill in this part here. So I have to do this here, A is -1, so it'll be negative y plus c. C is 5, so plus 5. All right, so we got -1/2 plus 3 is 2.5. I'm just going to do all my x's now. 0/2 is 0, and then plus 3 is 3. Half plus 3 is 3.5. 2/2 is 1, plus 3 is 4. All right, plug in the y values. -1/2 plus 5 is 4.5. -1 plus 5 is 4. -2 plus 5 is 3. And -4 plus 5 is 1. All those points look pretty easy to plot. I'm just going to throw my axis down through the middle for y, and then for x. So I'll do the base in green, -1/2. That would be about right here. -1, +1/2, 0, 1, 1, 2, and 2, 4. Okay, there's my base function. Remember, there's always going to be a nice HA, so it's really easy to graph. Okay, and now my transformed one, I'll do this in pink. So using all those points, 2.5, 4.5. So 2.5 up 4.5. That's right here. 3, 4, which is right here. Or 3. Oh, sorry, I got to go below. 3, 4. That's right here. And 3.5, 3. That would be. Sorry, 3.5, 3 is right here. 3.5, 3. Yeah, and then we have 4, 1. 4, 1. Okay, so this might be really weird to try to graph this, and you might even not even know where to start. You might be wondering, okay, does this go like this, or is it maybe doing something else? So one thing to keep in mind is you want to know where that HA is going to be at. So for the base graph, it was here, and the only way that this can move is during a vertical shift. It's going to make it go up 5. So drawing that is probably it's probably really good to do first even, just so you don't forget. That tells me my graph is kind of bound to that. So now when I see these points, I know I'm not going to draw and go through it like you might be tempted to. So we're going to go like this. And that's the graph. Okay, I'm just going to label it. Okay. One thing I do want to make sure is really clear. When you see questions that kind of look like this with the -2, the negative in front, be really careful that you don't make that mistake and think that the negative is part of the base. It's not. The base is just 2 for this, and then it's being multiplied by like a negative at the end. Okay, so really make sure you keep that negative separate. Okay, because this is not equal to this. Okay, those are not the same thing. Okay, because this actually means this. Okay, they're not the same thing. All right, so yeah, that's basically probably one of the hardest graphs you'll have to do. And I bet you if I would have showed this to you in the beginning of the year, you'd have no idea what to do. And now, it's just as easy as plotting y equals 2 to the x. You just got to make sure you apply the proper transformations to it. That's it for this video. I'll see you in the next.